Welcome back, dear students, to this new lesson of the chapter data structures. Today, we are going to look at the first dynamic data structure that we had on the chart we saw in the previous lesson. If you are not a member, I will encourage you to like, to subscribe, and to share, and encourage all the viewers of this video to drop a comment in order for our community to grow. Let us proceed. A linked list. A linked list is a finite sequence of elements, each of which contains a pointer field pointing to the next node. That's what we call a linked list, a finite sequence of elements. It is a dynamic data structure whose length can be increased or decreased at runtime, meaning that as you are running a program making use of a linked list, the size of that linked list in contrast to an array can either be increased or decreased based on the operations that are performed on this linked list. Each element in a linked list is called a node. So each element of a linked list is called a node. Each node stores the data relating to the element and a pointer to the next node. So that is how each of the nodes, that's what each of these nodes contains. The data it has to store and a pointer to the next node, because being a dynamic data structure, it is also a linear data structure. So they are all connected. Now, there is also a separate pointer that indicates the first element in the list, and it is called the head of the list. It has a null value when the list is empty. Meaning that what? We have a pointer called the head and it points to the first element of the list. And in case our linked list is empty, this head has a null value. In other words, it is termed a null pointer. Next point, the pointer of the last element in the list always points to a null value to mark the end of the list, as you can see. So a null pointer is what is assigned as the pointer of the last element. So you might be asking MCQ, when can we have a null pointer in a linked list? One of the answer is when the linked list is empty and the null pointer will be the head. And the last answer is when the pointer has values and that null pointer is for the last element. Look at this diagram that we have. A single linked list of 5 nodes. So this is the first node, the second node, the third, the fourth, and the fifth. And you see that we have our head, the start pointer, pointing to the first element, as you can see. And for the last element, you see that this pointer is marked X, meaning that what? It is a null pointer. For the other one, it's an asterisk. Remember when we were doing algorithm, we saw that an asterisk is what we use when declaring a pointer. That is why you see for every node, as said in the description, this is the value it stores and this is the pointer to the next node. The value, the pointer to the next node, the value, the pointer to the next node, the value, the pointer to the next node, the value. And since this is the last element, we have an X marking the end of the linked list. To implement a linked list, we use a record. Why do we use a record? Remember that a record is a composite data type comprising of either basic data structures or other composite data type. The pseudocode declaration of a linked list is given below. So I have my identifier equals to record. I have my data with a particular data type depending on what the linked list is storing. It can be an integer, it can be a character, it can be a string. Then I have a pointer called next, and its data type is what? Of type of the same record, meaning that what? It points to another node, because all these nodes are all the same. That is why this pointer has as data type the original data type we are declaring. As example, I can have linked list which contain the data, that is a linked list containing characters. So my data is of type character, then this pointer points to what? Another linked list. That what we say. Remember that this declaration does not mean that next is a linked list. No, it simply means it points to a linked list. Very important, dear students. Now, let us look at the differences between an array and a linked list. This is a vital difference that you need to know when it comes to data structures. The first point, array size is static and cannot change at runtime, while that of a linked list is dynamic and hence can be increased or decreased at runtime. That is the first and the primary difference between an array and a linked list, because it is just like the difference between a static and a dynamic data structure. The next difference, elements of an array are kept at consecutive memory locations, while elements of a linked list may be kept at any location but still connected to each other. So as explained in the last lesson under arrays, I explained what we mean by being stored in consecutive memory location, meaning that if I have the first element stored at location 1, if the next location is 2, that will be for the next value of the array, and so on and so forth. Now, for a linked list, this particular element could be stored at 300, while this could be stored at 500, this 700, this 800, and so on. That is what we mean by this difference. So the elements of an array are kept in consecutive memory locations, while that of a linked list are kept, they could be kept at consecutive memory location or they could be kept at any location, but they are still connected. But that is the use of this pointer. The next difference, random access is possible in arrays by simply using the index, whereas it is not allowed in linked lists since we have to access elements sequentially starting from the first node. What does that mean? If I want to access D, I will pass through T, through N, through J before arriving at D. If I want to access J, I need to pass through T and N. If I want to access E, I must pass through T, N, J, D before accessing E. That's another difference. Whereas in a linked list, in an array, sorry, I simply use the index. Another difference, arrays are mostly used when frequent random access is needed, e.g. lookup tables, whereas a linked list is mostly used when frequent insertion and deletion are required. And an example is what? ADT implementation. And ADT, we shall see it in the next lesson. ADT is what we call abstract data type. That is what we mean. So an array is mostly used in program where we need frequent random access, whereas a linked list is used when we need frequent insertion and deletion of data. Dear students, so these are some of the differences we have between arrays and linked list. A doubly linked list, remember that this linked list is also termed a single linked list. It is the same. Now, a doubly linked list, also known as a two-way linked list. A doubly linked list is one in which each node contains data it holds, the next node link, and a previous node link in the sequence. Remember, for a single linked list, every node just contains data and a link to the next node. Whereas in a double linked list, a node contains what? The data it holds, a pointer to the next node, and a pointer to the previous node in the sequence. Two links, the two links may be called forward and backward, or next and prev. This is from the word previous. The prev pointer of the first node and the next pointer of the last node are null pointers. I hope that we all understand that, dear students, because for the first element of the node, there is no node behind. That is why his previous pointer is null. And for the last element, since it is the last, it does not point to any other value. That's why its next node is null. This is a diagram we have for a doubly linked list of 5 elements. This is our first element. Remember, you see that for this first node, this is my value, this is my pointer to the next, whereas the previous is marked X, meaning that it is a null pointer. Again, I have my head pointing to the first node. For this second element, this is my, sorry, this is supposed to be the previous because it points back, and this is supposed to be the next. It points to this one. So, dear student, please, this is an error. This is supposed to be the previous, and this is supposed to be the next. When we come to this other node, this is the value we are storing. This is the pointer to the previous, this is the pointer to the next. For this node, pointer to the previous, pointer to the next. For this other node, pointer to the previous, and the next pointer is null, as you can see. So this is how a doubly linked list is represented. In order to define a doubly linked list, I have my identifier record, then I have my data type. Next and previous are all pointers pointing other um, to other nodes. That's why they are of the same identifier. Advantages of double linked list over single linked list. One, in a double linked list, we can delete a node even if we don't have the previous node's address, which is not possible in a single linked list unless we have a pointer to its predecessor. This is one of the most important advantage of a double linked list over a single linked list. What are we trying to say here? If I want to delete this n, as you are seeing, I can easily delete it even if I don't have the address of this one. Whereas if it's in a single list, for me to delete this particular node, I need to have the address of this one. I need to have this particular address in such a way that I'm going to map to this one for the linked list to still be connected. Another advantage is that from a node, navigation can be done in both directions. That is, from at this level, from N, I can only navigate forward. But here, from N, I can navigate backward or forward, which is the same thing for J and for D, which are the advantages of double linked list over single linked list. The last type that we are going to see is the disadvantages of double linked list over single linked list. And the disadvantage is that what each node in a double linked list has an extra pointer leading to more space. So this is the main disadvantage of double linked list over single linked list. Another one is insertion or deletion of a node in a double linked list takes a bit longer because of what? Of more pointer operations. Circular linked list, which is the last type of linked list. A circular linked list is a single linked list in which the last node contains a pointer to the first node of the list. So you see that in a single linked list, the last element has a null pointer, whereas in a circular linked list, the pointer of the last element points back to the first node. While traversing a circular linked list, we can begin at any node and traverse the list until we reach the same node where we started. Thus, a circular linked list has no beginning and no ending. This is what we have. You see that from here, this is the head coming to the first node. When I start, I move to N, from N to J, from J to D, from D to E, and from E, I come back to T. So this is what makes it to be circular, because this last element points back to the first element. Let us take this example just then. The littoral regional mock question 4I. It says, the table below indicates nodes, data, and address of each node. The nodes are arranged in the order A, B, C, D. Use an arrow as a pointer. Draw annotated diagrams of the following linked list. We have A, we have B, and we have C. Let us start with A. So this, because they say it is drawn in this order, A, B, C, D, meaning that this is my first node, this is the second, this is the third, and this is the fourth, A, B, C, D. So this is what I have. So my head, remember that the head contains a pointer to the address of the first element, and this is my first element here, A, and its address is 15A. That is why under head, since it has no value, that's why you have this cross, and the address is what? The address of A. Now under A, what do I have? The data. The data of A is 800, as you can see. And now A has a pointer to the next element, which is B, and the address of B is 8BO. That's why you have this particular value for node A. The value of A, which is 800, and the address to B, that I have 8BO. B now has its data, which is 100, and the address of C, which is C44. C has its own value, 500, and the address to D, and the address of D is what? 40D. Then D has its own value, which is 250, and since it is the last element, its pointer is null. That is the single linked list representation of this table. For a circular linked list, we will simply have the same thing, with the difference that the pointer of D will not be null, but it will instead contain the address of A, and the address of A is 15A. So the difference between this and this is that instead of having a null pointer for the last element, I simply have the address of the first element. For a double linked list, a little bit complicated but very easy. The head has the address of the head has the address of the first element, which is A, as you can see in these two cases. Then A, remember that for a double linked list, we said that the previous pointer of the first element and the last pointer of and the next pointer, sorry, of the last element are all null. That's why you have this and this are null. Now, this and this are the same. When it comes down to being, all these middle nodes are the same as that in a single linked list, with the only difference that we have again a pointer pointing back. So B has a pointer of A, which is 15A, and C has a pointer of B, which is 8BO. Same thing for D, it has a pointer of C, which is C44. So this is the representation of this table in a single linked list, a circular linked list, and a doubling linked list. I hope from here you have a brief and more knowledge when it comes to linked list, be it single linked list, be it double linked list, be it circular linked list. And this is the knowledge you need when it comes to Advanced Level Computer Science 795 under linked list. The differences between arrays and linked lists are very important. We shall come back to it again when we shall be examining the different cases and the appropriate data type or data structure to be used for particular algorithms. Remember, do not forget to like, to share, and to subscribe to this video. And I'm expecting, dear students, dear colleagues, for you to drop a comment at the end of this video, which will serve me as a feedback for the different videos of this channel. Thank you very much, and see you in the next lesson where we are going to introduce abstract data type. Thank you very much.